Okay, I left out k here. K is often associated with an integer, but here k I think could be anything, a complex number if you wanted. We'll just stick to real numbers. But so k, you can think of k as a parameter that's a real number, and each of these coefficients of this cubic are a function of k. And we're supposed to find the minimum sum of the roots without having a clue what the individual roots are. Now, we're going to make the assumptions that this is delta, rho, and omega are the roots of our polynomial. This, again, I believe this is called delta, Greek, rho, and omega. When you expand this out, you can see that minus the sum of the roots is the coefficient of x squared, which is totally lines up with this piece right here. Let me underline this piece and this piece. And you can see the minus signs conveniently go away. And if you don't understand where the minus sign comes from, just expand it out. The minuses just hang around, but minus the sum of the roots is what presents as the coefficient of x squared. Now notice we have a 7 here. So to get it in this form, to get this polynomial synchronous with this polynomial, we'll divide through by 7, and we'll get this right here would be minus. You see how the minus signs cancel. You divide by 7, and this is what we have to minimize right here. Again, you see how the 7 just came underneath right here, which was originally right here. Okay, so we need to minimize this, and this is very well known. It's just the numbers are kind of strange, but if we minimize this structure, we're going to know the smallest possible sum of the roots for any polynomial in this form. Okay, so this is equal to what? K squared and divide this 7, what is that? We would get, that's 22, did I get that right? 22 over 3, divide by 7, and this becomes 22 over 21. 22 over 21 is the coefficient of k. And then, of course, we get just minus 1. And again, I'll just perform this relatively simple task of dividing this through by 7, so we would have a monic, which makes it easier to complete the square. Now, a lot of you guys recognize what we're going to be doing right here. You just take half of the leading coefficient and rewrite it like this. Half of 22 is 11, so we have k plus 11 over 21 quantity squared. And we have to pay a price for this. Okay. When you expand this out, you get 11 over 21k twice, which is 22 over 21k. Now, the price that we pay is we still have the minus 1 hanging around here. But note that 11 squared is 121, 21 squared is 441. So we have to subtract off 121 over 441. I used to call this just correcting our mistake. In other words, we get this nice structure here, but this constant 11, this is 11 squared right here. This is 21 squared right here. And then when you do the arithmetic on that, the common denominator is negative, is 441. And so we'll end up with this part right here, just this piece right here. Let me circle it. Okay, is equal to minus 562 over 441. Minus 562 divided by 441. Now this is a little sloppy the way I've written it here. Really the equals doesn't really belong. But notice that if we choose k equal to, let me see that if I can make some attempt to erase that. Let's see, let's erase this guy right here. Okay, now, so when k is equal to minus 11 over 21, and this is taught in high school algebra, college algebra, middle school algebra, but that would make this part be 0, right? This part would become 0, and all that's left is this part right here. So this circle piece right here is the minimum sum of the roots. Okay, strange number. Now you could check this minimum sum. Let me write this sum, SOR, sum of roots, sum of zeros. Okay, and there's more we could do with this problem. You know, you could check some numbers out. Like for example, you could substitute k equals 0 in here. If you substitute k equals 0 in here, what would happen, folks? Let's go ahead and do that. If we substitute k equals 0 right here, you would just end up with 7x cubed. And again, y'all want to stress, we are done with the problem. The minimum sum of the roots is minus 562 over 441, but I want to see how close we are when we try some obvious parameter substitution. So if we do k equals 0, this will give 7x cubed minus 7x squared, right? And then you can factor out a 7 here, and so you end up with 7x squared times x minus 1, right? And so you can check these numbers. This would lead to x equals 0. And x equals 1, right? And if you sum those up, that's more, right? The sum of these roots is 1, right? Is 1, which is certainly a bigger number than this number right here. This number right here is a negative number between minus 2 and minus 1. And this is the smallest possible sum. It would be a little more difficult to find the roots. I'm not even sure how you would do that right now. It would be kind of hard, in fact. It would be tedious to find the actual roots themselves, okay? But for this special case, we got a sum of 1, right? For the case k equals 0. Down here, we had k is equal to minus 11 over 21, so we're just to the right. 0 is just to the right of minus 11 over 21 on the number line. But anyway, there's more we can do with this problem, but this does answer our question right here. Minus 562 over 441 is the minimum sum of the roots.